Hi, good morning, grade 12. We're all under national lockdown and I understand it's difficult for you. However, you're not on holiday. Without fail, you will be writing the end of the examination. So let's continue with our lessons that is important. We may not be facing one another, but it's important that we continue with work. Firstly, let us understand that you need to follow all your protocols in terms of your health requirements. Wash your hands regularly and stay away clear from people that are unwell and are sneezing and coughing. Let's get down straight away. In term 1, we did not complete a section called 2 and 3D, three-dimensional problem because of time constraints. This is a section which is an application of the sine rule and the cosine rule and also the area rules. However, in grade 12, we would use the compound angles incorporated in this question and double angles. Before we continue, let us understand what is a 2D and a 3D problem. If you look at the two diagrams here, this diagram here is a 2D because you don't have a perception of height. And you, the observer, are looking at this diagram head on. But this diagram actually represents some important facts about angles of elevation and angles of depression. This is where a person will be standing on a cliff and he's looking at an object bottom there, maybe a boat on a river or a plane on top. So that's an angle of elevation, angle of depression. An important thing to note that the eye level is always parallel to the ground level. Therefore, it helps us to get this angle, which is an alternate angle. Keep all these techniques in mind. Now, if you look at this complicated diagram, in this diagram, there are two things that you need to consider, or actually three. There are three different triangles here. There's a triangle ABD, triangle ADC, and there's a triangle BDC. Now if you notice that triangle BDC is shaded. In the exam paper, the examiners were told to shade that triangle because it lies on the horizontal plane. So anything that's gray is 3 points on the horizontal plane. The other two triangles are the two vertical planes, and hence it's a 3D because you've got a perception of height here. Let's suppose that AD represents a cell phone tower and there's a person B on the ground, horizontal plane, and there's a person C looking at the cell phone tower from two different points. The person B looks at the top of the cell phone tower and creates an angle of elevation of theta. The person C, looking at the top of the tower, looks at an angle of alpha, which is an angle of elevation. So these two are angles of elevation. So when doing these questions, you must have a perception of what is going on in terms of what angles are they referring to. One thing to note, it is the last question in your trig section of your paper. It is plus minus 10 marks, which is 3% overall. That 3% could be a level change, could be an A or a B if you get these things right. The more examples you do, obviously you become more proficient in the section. Practice makes perfect. Let us, before we continue with the lesson itself, go over last year's work. The solution of triangles of 2 and 3D involves two different aspects. One, it involves the solution of right angle triangles. And the solution of right angle triangle obviously requires a right angle, like the diagram that we saw previously. And in this case, you must be given the length of one side and an angle, then you'll be able to find another side using a trig ratio. It's not necessary, but something nice to know. Always start with what you want over what you have and equate it to a trig ratio that you know. Remember, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. So it gives you some kind of formatted learning or formatted way of answering the question. But using a right angle triangle, we can also find an unknown angle. In this case, you must know the length of two sides. So a known side, and a trig ratio that you of the angle that you want to find. Once again, using sine, cos, and tan ratios. And then you will find the inverse of it, and thereafter you can get the angles. Remember, in grade 12, they can either ask you a numerical question or a variable-based question, or maybe both. You will see an example of 2019 how they did both. What happens if we don't have a right angle triangle? Then we need to go through the three trig triangle rules that we have: the sine rule, the cosine rule, and the last one, the area rule. All three can be examined. The statement of the sine rule is important. This is last year's work. This is triangle ABC. Note that the side opposite the capital angle is always denoted as a small, and likewise. Things that we know. Two forms of right stating the cosine rule. Let the question determine which one. In this case, always have your unknown on the top ratio. You only need to know 2, and then you can find whatever that's given, and you can find angle A. If you're finding a side, in this case BC, which is A as a small letter, then always have that as an unknown, and then use the 2 trig ratios to work things out. The cosine rule is an interesting one because it involves the squaring of sides, very much like the Pythagorean theorem. However, there is an adjustment because we don't have a right angle. Once again, statement is important. Try not to just learn it as A, B, and C. Try to also use it like this: BC squared is equal to AC squared plus AB squared minus 2 times AC times AB cos of angle A. So that it gives you a perception, because you're dealing with many triangles and you cannot use ABC because there could be 2 angles that have a side opposite the angle A. Also, you could use the cosine rule for finding angles like we did here. What I omitted to tell you is when do I use the sine rule and when do I use the cosine rule. You would use the sine rule if you have 2 angles and a non-included, 2 sides and a non-included angle. Let me just repeat that: 2 sides and a non-included angle. This is included. Or if you are given 2 angles and any one of the sides. You would use the cosine rule if you have 2 sides and an included angle, and therefore you can find that. Or have that side, and you have that angle, and you can find that, and many other combinations. You can also use cosine rules to find angles, provided that you know the lengths of the 3 sides of the triangle. It's important that we concentrate and know the application of the sine rule and the cosine rule. Then the area rule helps us to find the areas of triangle, and we use the area rule if we know 2 sides and an included angle, similar to the cosine rule. However, give you an example. The area of triangle ABC using the same diagram is given by B times C times the sine of angle A, or half times AC times sine of angle B, or half AB times sine of angle C. Let us look at November 2019 paper. First and foremost, look at the total. It's 10 marks, so nothing more than 10, 3% of the paper. It is the last question, and generally there's an explanation of the diagram. This is important because it tells you a lot of things. So for example, in this case, they're telling you that in the diagram below shows a solar panel ABC. So ABC is a solar panel. Perception is important. Having a kind of visualization of what is going on is equally important. But it's important to read, because then they tell you that which is fixed to a concrete slab EFCD. So go to the diagram and let's look at the concrete slab. I don't know if you can see this in your diagram, but when you see it on original paper, you can see that EFCD is shaded. So that's lying on the horizontal plane, and this quadrilateral is inclined. Now, what we forgot to read, that they are both identical rhombuses. So now they're expecting us to remember all the properties of grade 10 geometry. And I want you, I'm not going to do this question now because it's part of your homework, your first example, and we will do this the next lesson, maybe in 2 days time. And I want you to go back and look for your grade 12 notes in geometry and write down all the properties of rhombus. Actually, write down the properties of parallelograms, rhombus, rectangle, kite, trapezium, because it's going to obviously help us in the trig and analytic geometry, which is our next section. But let's look at this question. So they give you further information. They're telling you that angle ADC is equal to angle CDE. Remember, it's a rhombus, therefore it's a parallelogram. And one of the things that we know now is opposite angles of a parallelogram are equal. So this could be 60 degrees. In fact, it is 60 degrees. And in this case, this angle EFC is 60 degrees. Let's not get into the details because I want you to do those things. Then, as I mentioned earlier, they'll give you a value in numerical form or values of lengths of side in an alphabetical form. So it's telling you X. Remember, it's a rhombus, and one of the properties of a rhombus are all four sides are equal. Okay, so that's an important consideration. Also, when reading, don't forget other important facts. Like two sides would be equal. Underline them or highlight them, but remember, in the final examination you're not allowed to use a highlighter, so underline them or ring it so that you don't forget important facts. Go slowly, be calm, be patient, just don't rush into the question. Don't start here, start with the instructions and translating all the instructions. So the first two questions are straightforward because obviously it is 2 and 1 mark respectively. The next question is 7 marks, so obviously a little extra work is required. Reading is also important. They now telling you that angle AKF, which is the angle between a solar panel and the concrete slab, so it's at an angle. So go back to the diagram and try to figure out what angle, what it looks like. Okay, AKF, it looks 90 degrees, but it is not. Perception is important. Okay, so I'll leave this question to you. Remember, they want you to find the area of triangle AKF in terms of X and Y. Let's concentrate on a worked out example. Example number 1 of the notes that we gave you when you were writing maths. So before we do example number 1, let's just look at something that is important. And we want to get a perception of whether you understand exactly what is going on. Just give me a few minutes to get the slide. I think I just deleted the previous slide. Okay, example number 1 of your worksheet. Let's check. All right. All right, now we're going to be there. Okay, let's look at a 2D example. In the 2D example, once again, let's concentrate on this whole exercise so we get an idea. It says in triangle PQS, M is the midpoint, so that's a keyword. If it's the midpoint, that means two sides are equal of QS. So you can see this examiner was kind to you. He marked the equal sides. Okay, and then they're now giving you some other additional information. They're telling you that QR is equal to RP is equal to RS equals to D. Although they did not label it for you, so you need to make sure that you understand that situation. So this is D, that's D. Point to note, can you see that triangle QRP is an isosceles triangle? So when labeling, be careful, that angle will be theta. This PRS is also an isosceles triangle, but however we don't have any angles, but I got a strong feeling that this here is too. theta because there's an exterior angle. So that is 2 theta. Then these two angles will be equal, and we can express that as 180 degrees minus 2 theta over 2. Remember your basic geometry question? So this angle here is 180 subtract 2 theta. Now we're getting straight into the question. Let's just hold on to the question. So we just got a feel of what's going on. It's important to spend about 30-40 seconds on this to give you an idea of what is going on and translating the information into the diagram. Do this for geometry as well. It's very helpful and useful. We want to prove this. As I mentioned earlier, it's going to kind of be a kind of identity question. Prove that angle A is equal to 2 times d sine of theta. And that's interesting because we have a bit of a problem. We have 2 theta, but they want theta. But if you look at the previous question, the one that we did on top, we can factorize. And can you see, this is going to be 90 minus theta. So this angle here is 90 minus theta, and this angle here is 90 minus theta. Please note there's no square roots, there's no square, so clearly I'm not going to use the sine rule, cosine rule. I would use the sine rule. And once again, the relationship is sine opposite the side. So let's get straight, let's get cracking. So this is an explanation of what's going on in the diagram. They made a note here. They give you an explanation why the angles are, like in this case, why is QPR theta? Because it's isosceles triangle. It's also nice to state which two sides. So in this case, it's QR equal to PR. Okay, then we know now, here's an explanation here of why this is 90 minus theta. Is speaking about RPS and PSR. Now, when you finish this video, take your notes out and go through what you've seen. If you're watching your cell phone, watch it sideways so the screen becomes bigger. So using the cosine rule, in fact, I wouldn't start here. I would actually write in which triangle I'm working. So in triangle PRS, comma, because that's where I want A. So I will write down PS over sine of angle, and we can call this R1. But remember, if it doesn't appear on your, at the end of the year, this diagram will appear in your answer booklet, so you can label it for the examiners to see. So in this case, I'll call it R1, or you could label it full and say PRS is equal to. Now look at something else that you know. Remember, we don't have variables. And we don't have measurements, so we have variables. So that's D and that's D, so you could use any one of them. So in this case, I could say RS over sine of angle P1, which obviously I call that to be P1. And then start here. And thereafter go here. I would recommend that. Do this. It gives you a good idea. So when you're reviewing your question, you have an idea of what you did. Your thought process has been concretized so that you know exactly what's going on. All right, so when you do this situation, you want to find angle A, cross multiply and divide. And then you have the situation. And once again, can you see you've got double angles? So therefore, it is a grade 12 application of the sine rule, cosine rule. And once again, the formula, and then co-ratios. And then sine of 90 minus theta is cos theta, therefore the cos and the cos will cancel, and therefore you're going to get the situation as we require, and you can get your answer as A equals 2 times D times sine of theta. And we're done. Look at the question. They said 2D sine of theta. Okay, you can also do, and then obviously you can simplify and you can get whatever you want, and you can try this. Now, one of the recommendations I expect you to do is to do this as homework. Now, not all of us are on the D6 communicator will get this video, but we make an appeal to you. If those of your friends who are not on D6, you can give import the link on WhatsApp and send it to all your friends who do mathematics, not necessarily in the V R KARSHAN's class or anybody else, the whole of the grade 12 maths learners. It's important that you do this question. During our next lesson, I will do a correction of this exercise. Now let's look at a 3D example. As I explained to you, a 3D question is a perception of height. It's always start with the triangle that's given. These are kinds of ideas like we did previously. There were 3 triangles. I started stating to the examiner which triangle I'm using. What I mean by this is I always like to write in triangle. It's a good practice. So when the person who's marking your script will follow your thought process. Remember, writing all over the show, he won't know where you're starting and where you're ending. Right? Link the triangle to the unknown side to be proved. Okay, we'll explain this linking just now. Mark off all right angle triangles if it's not already marked for you. It may not look like a right angle. Shade is now a law that you have to shade. The horizontal plane will be shaded. Remember, angles of elevation and depression always given or always taken from the horizontal plane, like the question that we saw in 2019. Always indicate in which triangle you're working. Very, very important, because you've got 3 different triangles. So when you're moving from one triangle to another triangle, it's important that you understand why and which triangle you're going to work with. Now this is a 3D question, very similar to one that we had. Fortunately for us, in this diagram the angles are labeled, but try not to use this because you can get yourself confused. But if it's done for you, then use it. Here's a perception of a 3D that is opened up. And can you see you've got this triangle here, and that triangle here. This is a horizontal plane, so clearly that's going to be your shaded area. Another good practice is for yourself. Maybe if you're working in that triangle, write on the side a small diagram and then work with that. Then you get an idea independently and you don't get confused. So you can work with that using your sine rule, cosine rule, area rule. In 3D diagram, things may not be what they seem, the perception. All the diagrams have 2 vertical planes and 1 horizontal plane, depending on the question. The previous question, they were quadrilateral. See how they changed each year. They moved away from triangles to a quadrilateral just to mess with your minds. 3. The next important thing, that the vertical triangles are folded open. That's what they're trying to say. They're explaining to you there. Remember that A angle B1, D1, D2, D3 have not the sum of, is not angle at a point, because remember there are 3 planes. Do not think that this is the diagram. This is a 3D diagram because these angles are in different planes, so they do not add up to 360 degrees. Something that you should consider. But let's look at a worked out example so that it gives you an idea of what is going on. So once again, in this diagram, this is in your notes. In this diagram, a person wants to determine the height of a tower A, B. Let's look at the diagram. Okay, I get an idea where's the height of the tower. Okay, so that's the tower. It's in the right angle triangle ABC. Alright, and it's from C on the same horizontal plane as the foot of the tower. So technically speaking, this should have been shaded. And an angle of elevation is alpha. So this is the explanation, but you can see it clearly labeled for you in the triangle ABC. Angle BCD is beta. Once again, that's a horizontal plane. And they're giving a third angle, which is angle BDC, which is theta. And they're giving you a variable for the length of the side, which is CD. Once again, can you see no numerical values? It's a common practice for examiners to do that. Can you see the question? This is an identity type of question. You have to prove this by using your sine rule, cosine rule, and solution of triangles. Right now, so the first thing we want to do is to analyze where we're going to start. Oh, by the way, the link side BC is the link side. The link side is the side that is common to both the vertical plane and the horizontal plane, and it will link to the side that you want AB. Now if you notice, even in the right angle triangle, even in a non-right angle triangle, you must have at least the length of one side. In a triangle ABC, we do not have that, so that's not where we're going to start. We look at the other triangle, BCD has two sides, two angles actually, two angles and at least one side, and that is useful. So we'll start there. Once again, let's check. I have two angles and one side, therefore the sine. Right. Now, whenever you see beta plus theta, then you must know that it's useful to understand that x is opposite this angle here, and therefore that angle is 180 degrees subtract beta plus theta. So it's kind of useful if you pull out triangle BDC and draw it here. So here's BDC. So that's B, that's, let's just go back there, C, and that's D. So this happens to be beta, and this happens to be theta. So now you can understand this is x. It's easier to work in this triangle rather than looking at the triangle. So in this case, CBD, and even if you wrote angle B and if you drew the small diagram, it is good because the examiner can see now that you extracted the triangle and you're working with it separately. Is 180 minus beta plus theta. That's what is important. Once again, the statement of the sine rule, BC, which is which is the link side. It's a link to the other side. So once I have that unit, then I can continue the other one. So BC over sine of D, can you see it's easier to do it here, is equal to DC, which is x, over sine of CBD. Put in all your information. And once again, can you see I stated which triangle I'm working with. Put in all your information, BC, which is important. Notice I didn't say small b over DC because it gets confusing otherwise. So rather use the statement of the sine rule in this manner. Alright, let's continue. So we put in all information. D is theta, and that's sine of 180 minus theta, and we know that this is a reduction formula. Okay, once you know that's the reduction formula, there's the application. Cross multiply and divide, cross multiply and divide by that. Always that's the case. Therefore you're going to get x sine theta over sine of beta plus theta. Now working with this triangle, once again, if you wanted, you can draw the right angle triangle, so you get an idea of basically what is going on, and that's alpha. So we want to find that. You remember the previous slide I said we know now this is x sine theta over sine of theta plus beta. A bit complicated, but you understand what I'm saying. So I want to find that. So once again, simple basic trig, opposite over hypotenuse, opposite over adjacent involves tan, and if you look at the question, there's your tan alpha. Okay, so that's the starting point. So it says tan of ACB is equal to AB over BC. Therefore, AB is equal to BC times tan of sine alpha, tan of ACB, and ACB is actually alpha. Therefore, it's x sine theta over sine beta plus theta times tan alpha, and you neaten up and you get your question. Okay, so that's a basic, very basic example, but it involved use of finding an angle, given two other angles, trig ratio, the solution of right angle triangles. At this stage, I want you to pause and then check this example, go back and check this example again, get a feel of what's going on. Let's look at example number 2. And example number 2 is an interesting one because it says in this figure there are 3 points in the diagram. In the figure, L, M, N are 3 points on horizontal plane, again supposed to be shaded, and from point M an angle of elevation to the top of the pole, KL is a pole, is X. Be careful, now it's not theta nor alpha, it's X. And if the length of the side LM is A, that's on the horizontal plane triangle, and they gave you a numerical value, LMN is 150. Good. Please note 150 is 180 minus 150 is 30 degrees. So can you see we got that kind of situation, and this is a special angle. And whenever you get in the question something like a square root of 3, then expect a special angle. I'm thinking maybe 30 degrees is involved there. Then you got 2 angle y, and you got that situation. Okay, let's start straight away. So clearly that is what I want. This is my link side. Start with the triangle that has most information. In triangle KLM, only one angle, no other side, but I can find that. So that's my starting point. So let's start straight away. Look at the identity. It looks ugly, but you'll be surprised how easy it becomes if you practice. And this is what I want you to do. I want you to take a blank sheet of paper and do this question again in your own handwriting, in your own style, and then follow the steps. If you start, follow the steps that we had in the example. All right, so let's go through this. So KL is equal to A tan. We need to prove this. KL must be equal to A times tan of X, in this case this triangle, into cos of Y minus square root of 3 sine of Y. Kind of two terms, looks ugly and complicated, but when you see at the end of the example, you'll be thrilled how easy it is. So obviously we want to start here. Now if I want to find LM, then I need to find this angle. It works in a side opposite the angle. So angle N is 180, subtract 50 plus Y, which is 30 minus Y. Very interesting. Now we want to find the length of the link side. So LM over sine of N is equal to LN over sine of M. Put in all the information. Once again, I mentioned which triangle I'm working because there are 2 different triangles. Put in all your information. So LM over sine of 30 minus Y is equal to A over sine of 150. So LM is equal to cross multiply and divide. And just be careful, I think okay, here we go. So it'll be A times sine of 30 minus 30 degrees minus Y over sine of 30, because I use special angles. Okay, and at this stage a recommendation is try not to use your calculator. Use the knowledge that you have. So there's a mark for writing this part here. Okay, and then I'm using compound angles. Amitabh Bachchan. There's my Amitabh Bachchan. Okay, the sine compound would be sine of 30 cos of Y minus cos of 30 sine of Y. A into sine of 30 is half. Now half dividing by half is actually multiplying the top by 2. Nice to know. So if I have A over half is the same as A over 1 times 2 over 1, and therefore that's 2A. Because I think in the question there's going to be a 2 somewhere. We're going to sort that out just now. Okay, so it'll be 2A. So you got rid of the fraction. Take the fraction to the top, it becomes 2. Sine of 30 is half. Cos of Y, cos of 30 degrees is square root of 3 over 2. Use your calculator in this case, not a problem. Times sine of Y. Now if I multiply the 2 in, can you see the half becomes 1? If I multiply the 2 in, can you see I got the square root of 3 over 2. Can you see you got this part and that part? Only tan is missing. Okay, I think you've got an idea what's going on. Now you look at this triangle, and an advantage for you is to draw the triangle next to it, separate it. so that you have an idea. Let's get our labels right, or it's the other way about. Okay, so we need to just erase this. And this is the triangle like that. Let's get our labels correct. So it's KLM, KLM. But now and then, please also look at the diagram. Remember, now we got this to equal to this ugly looking thing. Okay, don't write it down, you're wasting time. So let's go through this. It says tan of angle M, in this case, well, it's KLM, which is X, is equal to opposite over adjacent. Okay, cross multiply KL is equal to LM times tan of X, because that's X. But LM is what we proved there, and you got your identity sorted out. But I want you to go through this question again. Question number 1 and question number 2, both the 3 examples that I've done. Go them before you attempt your homework. Go through all your work. Watch the way in which we set up the question, which triangle, drawing the triangle one side, and then making important notes at the work. This question is between 7 to 8 marks, but they won't give you a total question. They'll break it up in 3 parts or 4 parts. Okay, let's look at your exercises for today, or there's an example number 3 which I leave as self-study. Self-study plus minus 15 minutes. Go through it, understand, and if there's a problem, we can discuss this when we meet. Remember, there's a square root, so I'm clearly feeling that they're going to use a cosine rule. So I want you to do this on your own. Don't want to keep you waiting for more than 40 minutes. Nice, interesting example. Watch these different stages. And your homework for today is November 2019 and November 2018. Let's just do 2, and the section will be done. Thank you. It's been a pleasure. Mr. Karshan signing off. Sound like a radio DJ. Wish you all the best. Please remember, be safe, be careful who you're meeting with, and stay at home and do your homework. Remember, although you are in a lockdown, you're not on holiday, divide your day into 3 sections, maximum of 40 minutes. Notice I'm not going beyond 40 minutes in terms of time, so that's a normal 1 period session. 1 section down. Nice question. Start with 2019 first and then do 2018. The next video will show you the solution. I'm giving you 2 days, so I'll see you on Friday. Thank you. All the best.